To Galileo Galilei, Kepler's theories, combining mathematics, mysticism, and magnetism, were as unacceptable as was Aristotelianism. Galileo had been brought up with an interest in mechanical things, such as Leonardo da Vinci's attempt in the 1400s to reproduce mechanically the natural flight of birds. Galileo also owed much to the recently discovered work of Archimedes, greatest of Greek mathematicians and inventors, one of whose water wheels is shown here. Galileo came to think of the universe as a huge machine, and of God as the master craftsman who had built it, set it in motion, and left it to operate on its own. With Archimedes' help, Galileo threw off Aristotelian ideas of space and motion and began to think in more abstract, more mathematical terms. By using an inclined plane with rolling balls, Galileo proved that Aristotle was wrong about the constant speed of a falling object, that a falling object actually picks up speed in direct proportion to the time it travels. Galileo extended this discovery to free-falling objects of unequal weight, deducing that they accelerate at identical rates of speed since they are subject to the same force. Galileo also deduced that a moving body will continue to fall forever unless some external force, such as the ground, stops it. Thus, he reasoned, a state of unending movement is as natural as Aristotle's state of absolute rest. With the telescope only recently invented, Galileo observed the moon and announced that it was not composed of Aristotelian quintessence, but of material much like that of the Earth. Galileo also used the telescope to observe the planet Jupiter. From a carefully maintained record of his observations, he discovered the 4 moons of Jupiter. If moons could orbit Jupiter, the planets could surely orbit the sun, just as Copernicus had claimed. Many other people were quick to agree. Galileo's opinions brought him into conflict with the Holy Office. This was the part of the Catholic Church charged with putting down all challenges to the orthodoxy of Aristotelianism as interpreted by Aquinas. But in the second half of the 17th century, Aristotelianism was to crumble before the onslaught of the new science. Galileo was the first truly modern practitioner. From careful observation and experimentation, including the use of precise mathematical measurements, Galileo gained exact knowledge through induction. He then tested this knowledge by using it to deduce new knowledge. Afterward, according to tradition, he tested these deductions at the Leaning Tower of Pisa. Galileo was able to see beyond the physical realities of the world, and by thinking in purely abstract mathematical terms, to form general concepts about the behavior of matter. Galileo was not fully modern. He remained convinced that Copernicus had been right about the circular motion of the heavens. In addition, Galileo could never imagine that an object moving into space might continue forever and never return to Earth. Nevertheless, it was Galileo who set the pattern for the development of science. During the next century, his methods were emulated by most scientists, the most significant of whom was the Englishman, Sir Isaac Newton.